Hi, welcome everyone to our last topic for the calculus part. We are going to do differentiation revision for your exam today. So let's dive right in. So for our agenda today, I'm actually going to split this video into 3 parts. So this video will cover the first part, which is the fundamentals and all the rules that you need to know for the differentiation paper. Make sure that you get yourself ready, get a pen out, a paper, have your calculator with you so that you can do some of these questions that I'm going to be giving you as practice. For today's goal, we want to review all the content that you should know, all the fundamental knowledge and the concepts that you need for your differentiation exam. Now, make sure you take notes of the topics that you're not familiar with or the topics that you would like to revise on so that you have that at the end. Now, for this video, it's going to be a long video or a long series of 3 videos, so make sure you make the most of it. Don't just sit there and watch the video and go from start to end. Have your pen and paper ready, write notes down, pause the video when I give you example questions to do. Actually attempt those questions. Check when I give you the solution that you do get the same solutions. Now, I will be telling you most of the students will ignore what I'm saying right now and just watch the video, and this is not the best way of learning. So make sure you get the most out of it. Do the practice examples. Remember, we learn math by doing, not just by watching. Cool. So for the first video, the topic is going to be all of the fundamental rules. Let's get started with our first topic. So first of all, what is the derivative? So the derivative is the function that gives us the gradient or the slope of the original function. And this can be done for any x value, any point on the graph. This is why we also call it the gradient function, because it gives us the gradient. You need to know the fundamental rules on how to get to this new function in order to use it. So now we're going to start with all of our rules. First of all, you should be very familiar with the power rule. This is for differentiating polynomials. The general formula or the rule for differentiating a power function where x has a power n, x to the n, is given over here as the derivative of x to the power of n is equal to n times x to the n minus 1. Now, with words, what do? I always recommend learning what the meaning is of this formula rather than learning the formula. So this means that we are multiplying the power to the front and then reducing the power by 1. So let's have a look at the example here. We have a function f of x is equal to x to the power of 5. If we now want to apply the rule, n is our power is 5. So we're going to multiply the 5 to the front, 5 times x, and now we reduce the power of the 5 by 1 to make it 4. So we get the derivative is 5x to the power 4. When we look at derivatives, we actually get a very nice setting. We have that the sum of derivatives is the derivative of the sum. Well, that sounds fancy, but all it means is that we can split our terms as long as we have a plus and a minus. So here we have got an equation with multiple terms. What we can do is we can apply the power rule to each of these terms one by one. So first we differentiate 3x to the power 4, which becomes 12x cubed, and then we do the next term one by one. Here I would like to note that for our x at the end, we have a negative x. So if we just have an x by itself, that differentiates to just a number. So in this case, minus 1. And if we have a constant, so a number at the end like plus 7 here, that differentiates to 0. So technically we have a plus 0 at the end, but we don't write that. Now, when we look at these questions, I also would like to note that the powers don't have to be integers or not even whole numbers in general. We can also have fractions as powers. So let's say we have our function f of x is equal to 3x to the power of 1 over 2. We can apply the same rule to find the derivative f prime of x is equal to, well, we're going to multiply the fraction, which is the power to the front. 3 times a half is going to be 3 over 2. Let me make that clearer. 3 over 2. And then we reduce the power by 1. Well, reducing the power by 1 is half minus 1. And if you're ever not sure, you can put this in the calculator, but that just means we have x to the minus 1 over 2. Now, why is this important? Well, because in the exam, you're most likely going to get a little bit of a difficult question. So you might get, let's use g of x this time. G of x is the square root of x to the power of 3. So how do you differentiate this? Well, from surds, which we knew from our algebra topic and the complex number topic, we know that x to the power of 3 has the power itself of half, because that is writing the surd form. A square root has a power of half. And if we have a power to a power, we can multiply the powers, which becomes 3 over 2. Now, what this means is we used something that looked like a surd and we rewrote it in terms of this x to the power of n form. And now we can apply our formula just like before. So in this case, if we want g prime of x, well, we multiply the power to the front. So 3 over 2 becomes in front. And now we reduce the power by 1. So what is 3 over 2 minus 1? Well, 3 over 2 is 1.5 minus 1 is going to be 0.5 or 1 over 2. Awesome. So what I'd like you to do is go through some of these questions. Pause the video, do some of these examples, over here. And if you want to, you can just do them in your head because these ones are still pretty easy. Just make sure you match them with the answers that I'm going to give you now. There we go. Awesome. So the next big topic is going to be the chain rule. The chain rule is one of the bigger rules that we use in differentiation, and we use it with almost everything. So I've copied here the formula sheet, which is dy by dx is given by f prime evaluated at g of x multiplied by g prime of x. Well, what does this mean? Again, we want to learn what the meaning is, not just what the formula is, so we can use it. So this means that we first differentiate the outer function f, and then we copy the inner function as it is, which is in our case g of x, and then we multiply at the end by the derivative of that inside function. So let's just do an example. I think it's much easier to see in an example. So here at the top, we have y is equal to 3x squared plus 1. And then we have a power to the 4. Usually, we recognize when to use chain rule when we have brackets. Anything in brackets usually means we need to use the chain rule. So what do? Well, the 4 is kind of like the power rule. It's in the power. So we move the 4 to the front. Keep the base, keep everything in the inside function the same, and then reduce the power by 1. This is what we did here. But now we still have to apply the chain rule, which means we multiply by the derivative of this inside function. This last step of simplifying is not required in most of the questions in the exam. This is simply for you to make the algebra easier for working out if you need it later on. You're welcome to leave your answer unchanged in this form. Now let's differentiate the second example. We have y is equal to sine of x squared. We're going to do trigonometry in a minute, but at this point I already assume you know how to do some of these questions. So if we now look at this, the inside function is again inside the brackets, so that's our x squared. So what are we going to do is we're going to differentiate the outside function, which is sine of x. That becomes cosine, and we see the inside function is just copied. We always copy the inside function. And then the chain rule says we multiply by the derivative of the inside function. Here are a few examples. Again, there might be some in there like the e to the x option or natural log at the bottom, cosine to the power of 3. Give them a go. But if you are not sure, come back to them later on, because we're going to cover on how to differentiate all of these in a moment. If you were wondering, here are the solutions. So, differentiating exponentials, anything with e to the x. Now in your formula sheet, again, I've copied it. The derivative of e to the x stays e to the x. Well, but be careful, and I'm saying this for every single one of the questions that you use the formula sheet for, because this x is misleading. If the x is anything else, then we need to use the chain rule, because then it becomes an inside function. So I rather have you remember that if you want to differentiate the exponential function, then you should just remember to copy the exponential term and then multiply by the derivative of the power. So let's keep that in mind and do a couple of examples. First, we have y is equal to 3x squared. Well, what did we say? If we want dy dx, we're going to copy the whole thing just like we had it before. The whole equation for the ex term is copied. But then we multiply by the derivative of the power. Now, for the second example, it's very similar. Now, we have a 5 in front. Multiplying a number in front doesn't actually do anything to a derivative. We kind of just like pull that through and keep it where it is. So let's keep the 5 in front. Now we have an exponential left, which is e to the 2x plus 1. Well, how do we differentiate e to the x? It's very easy. You copy the whole thing. Well, that was easy. But now we just remember the chain rule, which means we multiply by the derivative of whatever we have in the inside function. Again, here's some practice examples. Do these ones now. These ones you should all be able to do with the help that I've just given you with the 2 examples before. Here are the solutions. Now, these are simplified solutions, so try and use your algebra skills to get to these solutions to verify that you're right or wrong. The next part is differentiating natural logs. So in order to differentiate natural logs, we can have a look at the formula sheet, which tells us natural log differentiated is 1 over x. But again, in the formula sheet, x could be anything. So we need to remember the chain rule. And again, I rather have you remember a certain step or a certain meaning of this formula than just remembering the formula sheet. So I recommend that when you differentiate log or natural log, that you just copy whatever is in the brackets into the denominator and then differentiate it and write that in the numerator. So why does that work? Well, if we look at how natural log is differentiated over here, that just means 1 over, and we copy everything just like in the natural log brackets. That is our denominator. And then we have 1 over something multiplied by the derivative, Well, the way that fraction works, we can just multiply that into the numerator. Now, the reason why I like this form or this method of just copying and writing it in the bottom and in the numerator we're going to have the derivative is because for the integration topic we're going to have a form where we have the derivative on the top and the original function at the bottom, and that integrates to natural log. Well, that makes sense because we've basically got that rule over here. So again, here's some practice problems. Give these a go, pause the video, and make sure that you get these answers. Now, when we look at trig functions, we want to actually have our formula sheet with us. And that is because of some small things like negatives, when do we use that, or some more complicated formula which we just need to apply. So let's have a go at one example. Here we have our function f, which is sine of 3x. Well, the outside function is the sine, so we're going to have to differentiate that. Sine becomes cosine, and I've left the table for the rules there for you to have a look. So sine becomes cosine, but do you see how I copy the inside function again? Everything in brackets is always copied. And then the chain rule says we need to multiply by 3 because that is the derivative of the inside function. Let's have a look at this example at the bottom. We need to differentiate tan, so we're going to look at our formula sheet. Well, it tells us it becomes secant squared. Well, we just copy what's inside the brackets. That's very easy. And then what do? Chain rule, multiplying by the derivative of the inside function. Right, give these a go. See what you get. Over here, the last one, number 4, you should try and use the chain rule. We have sine of x squared is inside the brackets that have a squared outside. So give that a go, see if you can solve this. Awesome. The next part is going to be our product rule. Now, what does product mean? Product means multiplication. It comes from a multiplication question. When we have 3 times 4 is 12, 3 and 4 are our factors, so factor 1 times factor 2 is equal to a product. So the product is actually the answer to a multiplication question. So the reason why you need to know that is because this tells us when we can use the product rule. And that is specifically when you see multiplication for functions. Any two functions that are multiplied together, you're going to have to use the product rule. Now, we have covered before that if you have a plus or a minus, that you can just do them one by one. For products, this is not the case. So you need to identify when you use this. Right. So once you identified when to use the product rule, you can go to your formula sheet, and I'll move over a bit. This is the formula that you have. But again, I rather want you to remember what the formula means or how you can remember it rather than looking at the formula sheet. If you're used to using the rule at the end, fg prime plus gf prime, feel free to do so. Write down what f is, write down what g is, write down what f prime and g prime are, and puzzle them all together to match the product rule in the formula sheet. Now, the reason why I don't want this for you in the exam is because it's time consuming. So I highly recommend that you remember this sentence. The second times the derivative of the first plus the first times the derivative of the second. And go through in your head every single time when you do a product rule. Again and again, say it in your head because it will help you not just memorize the product rule, but also make you much faster at doing the differentiation because you can just do them as you go. So what does first and second mean? Well, in the formula we have f times g. So the first is the first function that we're multiplying with the second function. And now every time we say first or second, we just copy. Whatever the first or second is, we copy it. And if it says derivative of, well, then you take that part and you do the derivative. So let's do an example. Here we have f of x is equal to 6x squared times sine x. And here we see we have something with x squared and sine x. They're two separate functions with an x multiplied together. Well, our first term is 6x squared. Our second term is going to be sine of x. So let's apply our rule from above. So the second, which is sine x, times the derivative of the first, which is 12x, plus the first, copying 6x squared, times the derivative of the second, which becomes cosine x. Now you see, if you remember the sentence, you can immediately, from the start of a question, go to the answer in one step without looking up a formula or doing any other calculations and puzzling them together. So definitely give this a go for these questions. Here are the answers for your record. Awesome. And for the last part of our first part of this series is going to be the quotient rule. Now again, I have given you the formula sheet for the quotient rule, but do we really want to use that? No. Again, we want to find an easier way and a faster way, because during exam conditions, you're going to have to move very fast. So, do you remember the sentence that I taught you earlier? Well, for the quotient rule, we have exactly the same sentence with a small little change. Instead of plus, we now need minus. Well, you're going to have to remember that the quotient rule has a minus, and also you're going to have to remember that the quotient rule has the denominator squared. So whatever we have for our sentence is going to be going to the numerator. Now, first and second still applies to the same functions, but because we are looking at a fraction, the first is actually the one in the numerator, the second in the denominator. And again, we need to find out, when do we actually use this quotient rule? Well, just like product is the answer to a multiplication question, the quotient is the answer to a divided by question. So every time we're dividing two functions, or more likely a fraction where the numerator and the denominators are functions, then we're going to use the quotient rule. So you see a fraction, quotient rule. So let's apply some practice problems. Use the rule that I've shown you. Try and figure out what these are without going to the formula sheet. This also gives you a little bit of practice of some of the other rules that we've just learned how to differentiate. Awesome, wonderful. Here are the solutions, and I'll just move out of the way so you can see all of the solutions. Now, this is the end of our first part for the differentiation series. So make sure that you are good with all the fundamentals and the rules, and I'll see you in the second part.